Roberto Sorrentino. I'm a professor at the University of Perugia in Italy, and I will give you a short introduction about the topic of this webinar. So let's start with the definition of additive manufacturing, which is to ASM, which is the American Society for Test Materials. Additive is a process of joining materials to make objects from 3D model data, usually layer upon layer, as opposed to subtractive manufacturing methodologies. This is a booming technology, emerging technology, which is processing for RF application, which is actually the topic of this webinar. You create 3D with arbitrary chips, which are automatically layer by layer, with unprecedented flexibility and realization of complicated 3D structures. You can have a free line process from the constraints of conventional subtractive manufacturing techniques. So, from using additive manufacturing, you get fast prototyping, which is on accuracy, location cost, and fully 3D topologies. So, manufacturing started to be developed in the 1980s. Its popularity is quite recent, as shown by the number of papers published in the last 5 years. As you can see, more than half, 53% of papers published in the last year, in 2016. This proves the increasing popularity of this knowledge. As you see in the chart on the right-hand side, additive manufacturing encompasses a broad array of processes aimed to synthesize a 3D object from various raw materials using layer deposition. The being those shown here, from binder gene, power bed fume, and others. So this slide shows that the ASTM classification of the most important AM technologies. Most of them will be stated by my colleagues in the subsequent section of the webinar. So I'm not going to details of the various technology to leave more to my colleagues. So a few comments from my side, a personal view about advantages and disadvantages of this new technology. The advantage clearly that you can quickly and cheaply make prototypes, for example, both conventional or innovative waveguide components. One single piece, you don't have a split blocks, no process of contacts between metallic pieces, with clear advantages over conventional technology. On the other hand, however, there are still some issues concerning limited resolution compared to technologies. This can be still a problem, and surface roughness is still quite compared to conventional technology. So you may be finishing some processing of the component to get to the good performance that you need. In terms of developments, there are exciting perspectives about those. You can combine different AM processes, in them with conventional technologies, to fabricate multi-material electronic components, including plastic, ceramic, metal interconnects, and so on, in one single piece. And of course, there are significant improvements in terms of control topology and morphology, reduced cost, increased process speed. Also, those advances are expected in the next few years. It's as follows, the outline of the webinar. After the introduction, Tom Welch from the University of South Florida discuss about polymer and multi-material techniques. You see here pictures of devices built using these combined technologies. After Tom, Sorrentino from the National Research Council from Italy will discuss about developments of all metal microwave components using selective laser melting. And finally, Petronila from the European Space Agency in the Netherlands will